Hello, welcome to my presentation. My name is Semiha Köprü from Erciyes University Technology Research and Application Center. Today, my presentation title is Assessment of Metal Contents of Children Cosmetics Sold in Turkey. My presentation contains cosmetics and human health, child cosmetic products, microwave digestion and ICP analysis and results. Cosmetics and human health. The use of cosmetics by people of different social classes predates the invention of writing and has been associated with the pursuit of beautification ever since. Cosmetics is a term that encompasses more than makeup as defined by the National Poison Data System. These personal care products include a variety of products such as perfumes, nail polishes, moisturizers, eyeshadows, lipsticks, and share a common purpose. They claim beautify, stimulate attractiveness, or change appearance. The cosmetic sector has grown at an average rate of 4.5% per year in the last 20 years and has managed to become one of the most stable sectors despite the economic crisis due to the increasing demand all over the world. In recent years, the safety of cosmetic products and their ingredients has received more and more attention, hence their toxicological safety assessment is a new discipline and developed in the second half of the 20th century. The use of different instrumentation in the sorting, production, and packaging processes in the cosmetics industries can also cause metal contamination. Cosmetic products consist of different organic and inorganic substances, including hydrophilic and hydrophobic substances. The production of the colored cosmetics mineral pigments that cause contamination with heavy metals such as copper, nickel, cobalt, lead, chromium, cadmium, and other elements are widely used. The addition of additives and color minerals as the tip of the raw material used in production causes contamination. In addition, the water used for their preparation may also contain metallic impurities. Purified cosmetics do not affect the health of users. Despite this, some risks still exist for low-quality cosmetics that can affect the health of users, manufacturers, and distributors. In the study, most frequently used products in children's cosmetics were collected and analyzed by ICMMS. This study was conducted to evaluate element concentrations of selected elements in 3 different brands of children's cosmetic products, such as bright and colorful 22 eyeshadows, 4 lipsticks, and 4 nail polishes used by children in Turkey. Child cosmetic products. Color cosmetics are particularly interesting for women and girl children. Eyeshadow, lipstick, and nail polish are a group of cosmetic products that have been most commonly used in various parts of the world. There is very little information about toy makeup products. Toy cosmetics are usually sold in kits boxes containing different toy makeup products. The kit is a toy and each item in the kit is a cosmetic item. Widely available commercially, these products are applied to the thin skin of children's faces and often last as long as real cosmetics. Cosmetic products are often packaged and designed to be colorful, visually appealing, and easily open and used. Ingredients in cosmetics are often designed to smell good, like fruit or other foods, and a young child may mix the cosmetics with food or drink. The properties of children's and cosmetic products can position children to be attracted to these products, which can further endanger them. Lip cosmetics are one of the non-dietary exposure sources for metals. Lipstick products sold on the market in different colors as children's cosmetics can pose a health risk due to the toxic elements in their content. Another cosmetic that attracts the attention of children with a different matrix is nail polishes produced in different colors. Eyeshadow is a cosmetic product where the importance of pigments is great. Some toxic elements and their compounds are water-soluble, and percutaneous absorption of elements occurring as impurities in pigments can occur on moist skin. Sample preparation with microwave digestion. A suitable sample preparation step is still very important and essential for trace elemental determination. Sample preparation is always considered the most critical step during analytical sequencing and must carefully optimize to minimize errors. All samples were solubilized using the cosmetic method with the Ethos Easy microwave solubilization system. Microwave digestion method was used because it is short, fast, and the most recently developed this solution method. For sample digestion, 0.20 gram of the sample were weighted into microwave 100 milliliter PTFE containers, 3 parallel. Samples were dissolved by adding an acid mixture, nitric acid, and hydrogen peroxide, 921. After crushing, PTFE vessels were cooled to room temperature. The microwave digestion program for samples was operated under microwave conditions with a power of 1800 watts 4 minutes at a temperature of 210 Celsius degree. Second step was applied as 1800 watt for 15 minutes at a temperature of 210 Celsius degree. Digested children's cosmetic samples were filtered to remove undissolved particles. After cooling, the extracted samples were transferred to a 25 milliliter flask and diluted with ionized water. Before they were analyzed by ICPMS, analytical blanks were prepared in the same way. ICP analysis and parameters, the analytical approach based on the atomic spectrometric and chromatographic analysis allow the quantitative determination of toxic elements in cosmetics, among them GFAAS, PAAS, ICP or OAS, ICPMS. For example, ICMMS is a good choice for the determination of low analyte concentration, enabling the evaluation of toxic and potentially toxic components in cosmetics. Interference correction can eliminate molecular interference in the mass of interest and has the advantage of showing lowest detection limit. You can see analysis parameters volume. Results. In this analysis, standard reference material, human hair was analyzed for metallic elements utilizing same procedure to check the effectiveness of the digestion and analytical procedure. The results are given in table, you can see. And determine aluminum nickel elements concentration, microgram per gram for brand 1. And you can see determined copper and lead elements concentration, microgram per gram for brand 1. You can see. And brand 2 and 3 determine aluminum and nickel element, between aluminum nickel elements concentration, microgram per gram. You can see here. And copper and lead elements concentration, brand 2 and 3 shown in this table. And as a result of the evolution, the highest concentration of aluminum used as pigment was found in the eyeshadow, lipstick, and nail polish samples for brands, while the selenium concentrations were the lowest in lipstick sample. And Lipstick sample element concentration respectively is given, and nail polish samples element concentration respectively is given, eyeshadow samples element concentration respectively you can see, and the maximum levels in eyeshadows are given, the eyeshadows is given. Lead was detected in all tested 4 eyeshadow samples for 3 different brands and different colors in the range of 0.05 and 12.2 microgram per gram wet white. This range is below in all brands with lead content above 20 microgram per gram. The US FDA limit for lead is impurities in color additives used in cosmetics. Women and children are particularly vulnerable to lead exposure. The cosmetic and personal care products that are commercially available contain possible toxic content like metals. These metals can pose a risk to human health. Skin is exposed to such products repeatedly and frequently, which increases the rate absorption and risk of the unwanted effects regarding the increased level of these metals in this systemic circulation. So product choices are very important for health. At Noblement, this work was supported by scientific research projects chairmanship of Erciyes University, Kayseri, Turkey. Thanks for your attention. Goodbye.
Hi, dear Congress Secretariat and dear participants. I am Furkan Uzcan. I am a PhD student at Erciyes University, Turkey. My presentation title is Dispersive Solid Phase Microextraction of Rhodamine B on Nickel Silicium Dioxide Microspheres. Let's talk about contents. Firstly, I will talk about Rhodamine B, then dispersive solid phase microextraction. After that, experimental section, and lastly, I will talk about applications of our developed method. Firstly, Rhodamine B in industries like textile, food, paper, leather, plastic, and etc. Dyes are widely used. In general, synthetic or natural dyes enter the environment via wastewater. These dyes have both an aesthetic and sanitary impacts in nature. Rhodamine is a synthetic organic fluorescent dye. Is used in many industries as coloring agent due to its interesting bright color. Despite this, Rhodamine B represents a significant threat to environment and human health. It may lead to chronic poisoning, edema, pulmonary, and even cancer. FDA identified Rhodamine B as an carcinogen in 1983. So, its use in cosmetic, food, leather, paper, and other industries is prohibited. However, some countries still use this colorant. In this case, a sensitive and precise determination of rhodamine B should be considered an important task for us. But direct determination of rhodamine B at trace levels generally not possible by UVB spectrophotometer because matrix effects in real-world samples, as you know, and detection limits is high of this UV spectrometer. That's why we need a separation pre-concentration method to decrease the direction limit and reduce the matrix effects. Dispersive solid phase microextraction is a separation and pre-concentration method. It is a relatively new method to improve contact area between adsorbent and analyte. It's shortened the extraction time and decreased the sorbent consumption. The advantage of dispersive solid phase mixture extraction is reflected in the use of highly effective sorbents to improve the pre-concentration of analytes using only a few milligrams of sorbents. Like nickel microspheres could be used as sorbents, which has superior absorption capability. A core shell structure can be formed by coating nickel microspheres with silicium dioxide to protect their surface structure and also to enhance its absorption capability. In this work, we investigated the potential for Rhodamine B extraction on the nickel silicium dioxide microsphere surface using the dispersive solid phase microextraction method with UV spectrophotometry to achieve the highest extraction recovery and instrumental output. All parameters were systemically calculated using a step-by-step method. To check accuracy of the method, lip gloss, lipstick, lip liner, and rose water samples were used. Method is firstly a sampling solution was prepared by adding 2 ml of pH 7 phosphate buffer and 5 microgram of Rhodamine B in 50 ml of centrifuge tubes. After that, 15 milligrams of sorbent was placed in that centrifuge tube. Then the centrifuge tube, shaken by manually for 10 seconds, then centrifuged for 2 minutes. The aqueous phase was decanted and Rhodamine B retained adsorbent was eluted with 1 ml of ethanol. Lastly, Rhodamine B concentration is analyzed by UV visible spectrophotometer. In the experimental step, firstly, we optimized pH of the medium from 2 to 8 pHs. We prepared sample solutions, and as you see on the figure, is around 6, 7, and 8. It's around quantitative recovery we get. That's why we selected pH 7. Next, we optimized our sorbent amount. We start 30 milligrams with first, then we decrease the amount until 5 milligrams. As you see on the figure, from 30 milligrams to 15 milligrams is enough for quantitative recovery, but less than 15 milligrams is not enough for quantitative recovery. After that, a suitable eluent is needed to quantitative recovery. That's why we used acetone, methanol, ethanol, and acetonitrile. In figure you see, except acetone, the other organic solvents was enough for quantitative recovery. ethanol is selected, and after this, we optimize its volume. We start from 5 ml to 0.5 ml. Until 0.5 ml, we get quantitative recovery. So we selected 1 ml of ethanol and for further study. Lastly, we try to increase the volume of model solution, because the higher model solution is if we get higher volumes of model solution, so pre-concentration factor it also we get high. That's why we studied from 10 ml to 100 ml. We prepared different solutions for different volumes. For 50 ml it was okay, and below 50 ml it was okay, but 100 ml is not quantitative enough, so we selected 50 ml of model solution volume. Next, we add different interfering species on model solutions, and we applied our method in the presence of these interfering species. As you see on the table, we didn't get unwanted results. Applications, lastly, we used 4 different cosmetic samples, and we add different concentrations of these samples, and we get quantitative recoveries. Thank you for your attention.
You are all welcome. Thank you for coming today. I'm Nebiye Kizil. I'm an assistant professor in Hasan Kalyoncu University in Gaziantep, Turkey. Thank you for coming today. Initially, I want to thank you to the conference organizers. I'm glad to be here with you today. Today, I will present our new paper is about hydrophobic deep eutectic solvents, dispersive liquid-liquid microextraction of indigo carmine for spectrophotometric analysis. First of all, I would like to outline the presentation. It consists of 4 parts: introduction, experimental, results and discussion, and conclusion. In the beginning, we will talk about indigo carmine, which is our analyte. Indigo carmine is occurred naturally from indigofere tinctoria leaves, is frequently used in the food and pharmaceutical, textile, paper applications. On the other hand, indigo carmine is synthetically obtained from indigo dye via a chemical reaction with sulfuric acid. Indigo carmine causes dangerous diseases such as allergic problems, migraine, some tumor types, and also skin irritations. Due to harmful effects, both separation and analysis of indigo carmine in real sample is important. Too many methods are used for this. For instance, solid phase extraction, microextraction, liquid phase microextraction, or cloth point extraction. We investigated in this paper liquid phase microextraction by adding deep eutectic solvents. Deep eutectic solvents are green solvents formed by combining 2 or 3 solvents in a certain concentration, connecting each other hydrogen bonds. Deep eutectic solvents are synthesized by heating low temperatures. There are different types of that are synthesized. Experimental. Firstly, we was synthesized in this paper deep eutectic solvents. For this purpose, heating technique was utilized. The solvents were tetrabutylammonium bromide and deconoic acid mixed in a ratio of 2.1 at low temperature until they were completely dissolved. Then they were cooled in the room temperature for utilizing optimized method and feature studies. Here the method is illustrated. 5 milliliter sample pH values have been arranged as 3 with buffer solutions. Then 500 microliter deep eutectic solvents was added. After that, 300 microliter tetrahydrofuran is a protic solvent was utilized in order to extract the dye from aqueous phase. The solutions obtained were placed into ultrasonic bed for cloud formation. Then the mixtures were centrifugated for 5 minutes. Finally, solutions were analyzed using UV visible spectrophotometer by adding 1 milliliter ethanol. Results and discussions. pH is the one of the crucial parameter in the study. Therefore, the method was applied to the model solutions adjust between pH 2-4. The recovery values were shown figure 1. It is clearly understood that quantitative recoveries were occurred at pH 3. In this part, the effect of various types of the deep eutectic solvents have been scrutinized on extraction of indigo carmine. The highest extraction efficiency was obtained by using tetrabutylammonium bromide and deconoic acid. Deep eutectic solvent volume. In this part, volume of deep eutectic solvents was investigated. For this, 100 between 700 microliter deep eutectic solvents were used to extract indigo carmine. Optimum deep eutectic solvent was occurred as 500 microliter. And tetrahydrofuran was added to sample solution. Volume of 100 between 500 microliter. The highest recovery values are obtained 300 microliter tetrahydrofuran was used. Sonication and centrifugation time. In the light of the results shown figure 5, it seems that the centrifugation time of 10 minutes is sufficient, and also the best extraction efficiency was obtained at sonication time 3 minutes. Sample volume. To occur high preconcentration factor, sample volume effect was investigated. The sample solutions volume in the range of 5 between 20 milliliter were studied. The applied the method quantitatively until 15 milliliter sample volume. Due to the fact that matrix components define the selectivity of the device method, effects of some dye and some ions on the method were investigated. All quantitative result in tolerance concentration were listed in table 1. For the analysis of indigo carmine, the method was studied on real samples like energy drink, color chocolate, chewing gum, candy, nail polish, or some fruit soda. And also the accuracy of the method was demonstrated by adding standard solution of indigo carmine to the energy drink at no concentration. The results in table 2 show that the method is applicable, accurate, and successful. In addition, the method was directly performed some real samples illustrated in table 3. Some analytical parameters such as relative standard deviation, pre-concentration factor, limit of quantification were calculated as given in the table 4. The method presents low limit of detection and limit of quantification values. And finally, we can see table 5 comparison of device method with other studies. I would like to thank you, RGS University and Hasan Kalyoncu University for their support to this research paper. And I would like to thank my supervisor, Dr. Professor Mustafa Soylak and his research group. Thank you for attention.
Hi, my presentation is related to a review paper with the title of Magnetic Covalent Organic Frameworks Based Adsorbent in Solid Phase Extraction of Trace Analytes in Environmental Samples. These sections will be briefly described in this presentation. Sample preparation is one of the significant steps for analyzing process in order to pre-concentrate and separate the trace amount of analytes from different real samples. Among different strategy of sample preparation, SPE means solid phase extraction is highly effective techniques that's widely used for extraction and concentration of molecules and ions. Magnetic solid phase extractions means MSPE, which is a subset of SPE with outstanding features like simplicity, reusability, effectiveness in avoiding high pressure, easily separation in adsorbent, and etc. The use of external magnets in order to separate an adsorbent, separate the adsorbed analyte on the surface of magnetic sorbent from the bulk of the solution, and make this technique faster, easier, and much more effective than other SPE techniques. In order to increase the adsorption ability with different kind of analytes via various type of interaction, followed by increasing the extraction recovery, it's better to composite the magnetic nanoparticle with other nanomaterial. Among these material, covalent organic frameworks, abbreviated as COF, have attracted much attention due to their exceptional properties like absence of heavy and toxic metal ions in its structure, thermal stability, uniform porosity, extensive pore structure, and etc. Magnetic covalent organic frameworks, which are called MCOF, represent a new category of magnetic non-composite that combine the advantages of COF with magnetic properties. The exceptional characteristics of magnetic COF include the enduring porosity, various synthesis techniques, elevated physicochemical stability, and robust magnetic reactivity. In general, there are two main synthesizing strategies for preparing magnetic COF. In the first one, by growing the porous COFs as a shell on the surface of magnetic material, and the final product will be achieved. And in this process, as you can see in this picture, first of all, magnetic particle like Fe3O4 will be synthesized, and after that the surface of this material will be functionalized with other organic group, and then in the last step, the cuff layer will be coated on the surface of the magnetic material. In the second strategy, by growing the magnetic nanoparticle on the surface and pores of the cuff material, we can achieve the final product. In this strategy, since the raw material for synthesizing cuff have a very low density, so only by using 5 to 10 weight percent of magnetic material, we can achieve a very low density magnetic cuff at final stage. Magnetic covalent organic framework have a very outstanding characteristics like magnetism, functional group, pore size, and reusability. Regarding the magnetic features, this feature is typically evaluated at room temperature using a vibration sample magnetometer, abbreviated as VSM. If there is no apparent hysteresis in the curve, so it means that this material has supermagnetism like a bare magnetic nanoparticle. But by covering the surface of magnetic nanoparticle by cuff layers, we can see the decrease in saturation magnetization value. And by changing the content of the magnetic metal precursor substance, we can easily control the magnetic property of magnetic cuff. Functional group that is created by post-modification process are one of the crucial factors in the influencing their absorption capacity, selectivity, and magnetic properties in addition to magnetic characteristics. This picture give magnetic cuff outstanding properties like high crystallinity feature, effective mass transfer, and improve binding affinity between the M cuff adsorbent and target analyte. Pore size is another feature of magnetic cuff and is important during the adsorption process since it has a significant impact on dispersion of adsorbent and accessibility of the active binding site. And also the adsorption behavior, including kinetics, capacity, and selectivity, is significantly influenced by pore size. And these features will be measured by into adsorption desorption isotherm and the BET method. And regarding the reusability, since the raw material for synthesizing cuff are very expensive, so it's critical to combine the magnetic nanoparticle with cuffs to produce more cost-effective material. And to evaluate the reusability of magnetic cuff composite, we can use the numerous adsorption-desorption cycles. There are different type of synthesizing method for preparation of magnetic cuff, like solvothermal, photochemical, impregnation, precipitation, and mechanochemical process. For instance, regarding the mechanochemical process, in this technique, isn't necessary to use a solvent. This technique is very straightforward, quick, and effective. And the addition of acid as a catalyst can reduce the time of the reaction to only 10 minutes. And it can be mass produced using the apparatus like ball mills. And this technique involves the application of mechanical energy through various means such as shear, friction, impact, and etc. to alter the structure, physical, and chemical properties and chemical reaction of solid and liquid matter. Compared to other synthesizing method, this mechanical construction of magnetic cup is more cost-effective and eco-friendly, so it will be used as an optimal technique for large-scale and rapid preparation of magnetic cup. After synthesizing magnetic cup with various type of synthesizing method, and also after the characterization their features with different type of analytical instruments like SEM, TEM, XRD, XPS, FTIR, and etc. We can use this outstanding adsorbent for pre-concentration, extraction, and separation. The various type of analytes like PAH, marine biotoxin, pesticides, EDC, heavy metals, drugs, and other contaminants from the different complicated real samples. As a conclusion, it can be said that magnetic cup have their exceptional inherent and ascorate properties in the solid phase extraction method as an outstanding adsorbent to selectivity capture the target analyte from complex matrix. They have very prominent features like large specific surface area, reusability, high adsorption capacity, strong magnetism, permanent porosity, and etc. But there are some shortcomings in the stage of synthesizing magnetic cup as well as the application as an adsorbent, which requires more research to be fixed and modified. For example, the cost of the material is obviously increased by increasing the number of preparation process used for magnetic cup, which are often labor and energy intensive. Additionally, it can be difficult to add some functional group to magnetic cup in order to increase the selectivity because some cup structure don't have modifiable reactivity group. And as some solution for overcoming this shortcoming, we can suggest to create a new and affordable organic ligand and also using the moderate and quick preparation and using protective coating for surface modification, and also creating a magnetic CTFs and other types of inexpensive magnetic cup. Thanks a lot to Scientific and Technological Research Council of Turkey, means TÜBİTAK, Professor Soylak's research group, and also thanks to Erciyes University. Thanks a lot for your attention.
Hi everyone, thanks for this Congress, ICMMS-5 Congress. Thank you for your time. My name is Özgür Özel from Erciyes University from Turkey. Our title is Graphene Oxide Impregnation Natural Eutectic Solvents for Solid Phase Microextraction for Cadmium from Environmental Sample by Flame Atomic Absorption Spectrophotometry. My groups contain for Professor Mustafa Soylak and Abdülhamit Köri and Ms. Özgür. And then first of all, my title is for this, like you can see, for cadmium. Cadmium is very toxic metals. It's heavy metals because increase 5 gram per centimeters. And then anthroponic activities after and comes to cadmium pollutions and this accumulation on our body, and damage bones, liver, and kidney. And World Health Organization say, and limit is it 3 and 5 ppb. After this concentration, very toxic. You can see for organs, our human organs, and after deposition and accumulation comes to very big hazardous problem. And then solid phase microextraction contain for fast extraction, solvent-free and high pre-concentration factor. And people, researchers using different type of adsorbent like multi-volute carbon nanotube and for silica gel. But our adsorbent is new generation. We use graphene oxide, impregnation, natural diprotectic solvents for cadmium extraction, and very sensitive and accuracy. And what does it mean, natural diprotectic solvent? You can show for hydrogen bond donor and hydrogen bond acceptor combine, and melting point is very low. This is for homogeneously clear and observe. And we use for hydrogen bond acceptor choline chloride and hydrogen bond donor glucose. This is for natural. And different type of extraction and dyes, organic metals and pesticides. And diprotectic solvents, high viscosity, high thermal stability, and non-flammable properties contain. And you can see for common hydrogen bond and acceptor and donor, you can see left is acceptor, right is donor. And I say glucose and choline chlorides, and very important for natural diprotectic solvent. And after combine and observe, and you can see for molecular electrostatic maps, choline chlorides, and it's contain white is hydrogen, gray is carbon, and blue is nitrogen, green chloride, and red is oxygen. Preparation of graphene oxide impregnation, natural diprotectic solvents. And you can see for graphene oxide from Hammer's method, choline chlorides and glucose only adding in the becher glass and only apply to like approximate 100 centigrades, and after combine, and you can observe natural diprotectic solvent. And we use for graphene oxide only 2 grams and adding ethylene glycol. And after mixing, we add natural diprotectic solvents in ethanol, because solubility is very high in ethanol. And after 30 minutes stir and graphene oxide surface impregnation, natural diprotectic solvents, and after centrifuge, and you can see like graphite powder and apply to Hammer's method, you can observe graphene oxide. And after natural diprotectic solvent adding and surface on the graphene oxide, modified natural diprotectic solvent, and adding cadmium and buffers, and cadmium extraction is very good. Characterization of graphene oxide natural diprotectic solvents. First of all, we use FTIR spectrum. You can see only difference for disappearance for carboxylic acid peaks. You can show release for approximate 3000 centimeter minus 1. And second for characterization is XRD spectrum. You can see for green is composite, blue is natural diprotectic solvents. It is amorph, and after combine, you can see different type of diffraction peaks. And third of all, and NMR, proton NMR, you can see. And completely after choline chloride and glucose and water, 36 hydrogen observe. And then after combine graphene oxide, and different type of hydrogen is removed and combine is very successful. You can see for 8 hydrogen peaks. And for 4 of all thermogravimetric analysis, natural diprotectic solvents after 300 centigrade and decompose, but graphene oxide after 1000 centigrade still contain cause for carbon. And then last of all, SEM and EDX, you can see different type of an SEM image, and you can see for small drops, this is for naturally protected solvents, surface is graphene oxide. And EDX contain different type of elements, carbon, nitrogen, oxygen, phosphor, chlor, and mangan from potassium permanganate. Optimum experimental design, and you can see for procedure, cadmium and pH 7 buffer. After mixing, adding for nanocomposites, and after mixing and centrifuge, upper phase is removed, and we add nitric acid, and then again same procedure, stirring and centrifuge. We can analyze this with atomic absorption spectrometry, and we use apply for pH. pH optimum is 7, adsorbent amount, a different type of adsorbent amount. We select 20 milligram, and optimization, absorption and desorption vortex time is both of them 30 seconds. And optimization and sample volume, very important for pre-concentration factor. We select 30 milliliters, and effect of eluent concentration and different type of eluent concentration. For nitric acid, we select for 0.1 molar. And last of all, optimization is eluent volume. We select 0.4 milliliter. And for pre-concentration, calculate 30 per 0.4 equal 75. And last of all, result and discussion. Graphene oxide naturally protected solvent synthesized for to develop SPME method was for the first time in the literature accurate, sensitive, and selective precise determination of trace level of cadmium analyte, environmental food and water sample, and graphene oxide naturally protected solvent nanocomposite with large surface area due to nano-size pores, very simple synthesized steps, and high selectivity for cadmium. And last of all, high extraction efficiency compared to literature. My work, our work is this. Thank you for listening, patience, and for useful organization. Thank you for 5th Hybrids International Conference on Molecular Modeling and Spectroscopy for Egypt. Thank you for all of this useful Congress. This is useful organization. Thank you and goodbye.
Hello everybody. This will describe development of an optical glucose biosensor by using glucose imprinted polymer and immobilization of glucose oxidase enzyme along with a pH responsive dye. Glucose sensor has important application value in physiological sensor related to health and medicine care. Diabetes is a common disease that endangers people's health. Patients need to be regularly monitored for blood glucose in order to receive timely and correct treatment. The traditional fingertip blood collection method often brings physical pain and psychological pressure for patients. It is particularly urgent to develop a non-invasive and variable glucose sensor. As an innate body fluid, human saliva contains various physiological marker which could realize the non-invasive measurement of human glucose level. In present world, the performance of molecular imprinting polymer and glucose oxidase and bromotimol blue as a wet colorimetric indicator of glucose was investigated. As we can see in this figure, when glucose first glucose adsorbed on surface of adsorbent, then it's by using of glucose oxidized to gluconic acid. Gluconic acid had an acidic compound, and after adding indicator, in this case bromotimol blue, we see a color change of indicator. We have a color change from blue to yellow because in time the indicator is blue in the neutral, and then in acidic medium color change to yellow. For synthesis, first step is for preparation of this non-adsorbent. First we must use a core for this, and selected core is DIF8 because of high porosity. For synthesis of this procedure developed by Pan and co-workers in aqueous solution and room temperature was used. This figure shows the structure of this. It contains zinc and methylenimidazole. In the next step, on the surface of this 8 nanoparticle, polymer coating synthesized. For synthesis of polymer coating, we use methacrylic acid as monomer, ethylene glycol dimethacrylate (EGDMA) as crosslinker, DIF8 as core nanoparticle, and IBN as initiator of polymerization. In the next step, a structure of nanocomposite must be confirmed with FTIR and SEM image. In this slide, we can see the FTIR of DIF8 in up and DIF8 coated with molecular imprinting polymer in down. As we can see in the figure, we have a peak related to imidazole, zinc imidazole complex, and confirmed preparation of DIF8. Also, we can see in blue one, we can see peak related to polymer, peak of CO, pH, and OH. We can see in this spectrum. In the next step, SEM image was considered. We can see the cubic structure of DIF8, and also we can see the DIF8 coated with imprinting polymer. This SEM image confirms the size of nanoparticles, and this size is below than 200 nanometers. In the next step, we must prepare a calibration curve for preparation of calibration curve. Glucose in different concentration was separated by imprinted polymer after absorption and removal upper phase. 100 microliter glucose oxidase and 1 milliliter indicator were added, and color change were recorded by a smartphone. Development of a smartphone application for RGB profiling. The RGB profile of the sensor with respect to glucose concentration was determined using our own smartphone-based Android application, color detector and catcher. The application was used to determine RGB pixel, and then this data used for preparation of calibration curve. This figure shows the change of color of indicator in different concentration of glucose. As we can see, first the color of adsorbent is blue, then it changed to yellow based on formation of gluconic acid and we can see more color of yellow. We prepare different calibration curve based on RGB result. We have a calibration curve for red, green, and blue color. The first one is for red color. We can see the increase of red color with increasing the concentration, and there is a good correlation between concentration and changing of red color. For green color, correlation is not very good, and in this we can see result. For blue color, there is a good relation between increasing concentration, but in blue color we can see decrease of intensity of blue color. The best result is for red color. In the final step, for real sample and application of our biosensor, we use saliva sample applied on the surface of polymer. After absorption and removing upper phase, 100 microliter glucose oxidase and 1 milliliter indicator were added, and color change were recorded by a smart. Results also compared by commercial glucometer, and results are in good agreement together. Finally, the Erciyes University and Scientific and Technological Research Council of Turkey, TÜBİTAK, is greatly appreciated for supporting this project. If there is any question, you can ask me now or by this email. Thanks for your attention.
Hi dear participants, we are talking about halal and haram cosmetics products. In these days we have a lot of rules for Islamic life's conditions. We know that some religions have bring some hard rules. We are aware when the lines of these strict rules in some religions affect your lives very clearly. But we must not forget that we are all human beings. We cannot have help yourselves from the fact that everyone sometimes wants to bend the rules. Considering the world population, we can see that some marketing tactics have emerged and steered the market for years in order to enlarge the market and achieve the intended profit. In this sense, the title of halal cosmetic products emerged as the slogan of a new market formation. Why are halal cosmetics important? Halal means permissible or lawful. It is related to object or action which is permissible to use or engage in according to Islamic Sharia law. In terms of consumer goods, basically all things in the world are halal unless there is a prohibition maintained in Al-Quran or Hadith. Haram means prohibited or unlawful according to Islamic Sharia law. When we look at the world population on a global scale, we can mention that there are 1.8 billion people who accept Islam as a religion. Substances that are strongly prohibited by Islamic societies actually limit the living conditions of Islamic with a sharp line. The substances strongly prohibited by Islamic communications are not found in skincare and body products of halal cosmetics. The term halal cosmetics is an innovative approach in the cosmetic industry considering the Islamic production. A longitudinal view of the halal cosmetics market, according to MMR reports, halal cosmetic market trend is growing hugely. The reports say that in 2021, these marketing has cost in $28.32 billion. This cost number is so effective in marketing. These current figures cause the attention of all world companies dealing with trade to this market. And if we continue according to reports of MMR company, it is expected that this current value will increase up to $18 billion cumulatively with an annual growth of 15 between 2022 and 2029. These figures cause the halal cosmetics market to take its place among the foreign trade export products of developing countries with the lines. Why we focus on halal cosmetics analysis? One, the importance of inspected products of a rapidly growing market. Two, the fact that every product produced is only halal certified creates an environment where human health concerns are ignored. Three, audit whether the product raw materials and process have a control mechanism in a controlled manner. Four, providing a different perspective on the analysis parameters required for each product produced against the size of the market. The importance of inspecting products of a rapidly growing market. Every rapidly growing system in the world actually carries some negative returns in itself. Unfortunately, it is affected now by the whole world that the control mechanisms are not fully functional in every rapidly growing system. The fact that every product produced is only halal certified creates an environment where human health concerns are ignored. We all know that the certificate issued for some products do not meet the answers to all questions about the product. In this process, the term halal certificate, which emerged as the slogan of this market, cannot actually answer all questions. For this reason, it will become a necessity in time for each product to be subject to different analysis procedures. Audit whether the product raw materials and procurement process have a control mechanism in a controlled manner. In fact, the advantages and disadvantages inherent in the product itself are inherently like to the raw materials used in the production process. To summarize, it is vital to keep track of which raw materials are used in the creation of products. Providing a different perspective on the analysis parameters required for each product produced against the size of the market. A review of the literature clearly reveals the lack of an analytical procedure that has yet to be developed in this fight. With the development of analysis methods in this fight, it will be inevitable to develop new production and control mechanisms that will affect the whole process, and this will positively affect the process. Why we need analyzing of heavy metals for halal cosmetic products? Heavy metal analyses have been one of the primary sources that adversely affect human health at a high level for years. The analysis of these heavy metals, which have a primary effect on human health, has become an essential issue for the balance of the control of the human environment ecological system balance. You can see that some environmental effects from heavy metals. Some environmental effects caused by different types of heavy metals are shown in the graph on the right. Literature studies on heavy metals show that analysis of 6 metals are important. Experimental applications of halal cosmetic products. In this study, we examined top sellers of halal cosmetic products. Top selling products on the list are lipstick, eyeshadow, and powder, respectively. Products of these 3 products with 3 different brands, which are seen as leaders in the market, were examined for heavy metals determinations. Experimental applications of halal cosmetic products. 3 different products were dissolved in a mixture of nitric acid and hydrogen peroxide at the specified rates and transferred to a Teflon container and added to microwave system. After thawing in the microwave system for 35 minutes at 1800 W at 210 degree, a total of 13 heavy metal analyses were carried out in the ICMMS system for the samples diluted 25 times for heavy metals determination. The results obtained for lipstick in analysis of all brands show a high content of aluminum heavy metal. Other heavy metals that followed continued as iron, zinc, and manganese respectively. Brand 1 lipstick, nickel, copper, arsenic, and selenium. Brand 2 lipstick, nickel, bakır, arsenic, selenium, lead, mercury, and iron. Brand 2 lipstick, nickel, bakır, and lead were not found elements. In the results obtained for the powder in the analysis made for all brands, it was shown that iron, aluminum, manganese, and zinc heavy metals were found at high rates. Occurrence of brand 1 powder, nickel and copper, brand 2 powder, mercury, nickel, copper, and zinc, brand 2 powder, mercury, nickel, and copper were not found elements. Analyses for all brands show that the results obtained for eyeshadow contained high amounts of heavy metals such as aluminum, iron, manganese, zinc, and chromium. Nickel and copper in brand 1 eyeshadow, demir, bakır, iron, copper, zinc, cadmium, and mercury in brand 2 eyeshadow, nickel, copper, arsenic, and mercury in brand 2 eyeshadow were not found. Experimental applications of halal cosmetic products. In this study, we examined the top sellers of halal cosmetic products. The top selling products on the list are lipstick, eyeshadow, and powder respectively. Products of these 3 products with 3 different brands, which are seen as leaders in the market, were examined for heavy metal determinations. ICMMS analyzes results of halal cosmetic products. As can be seen from the table, the highest and lowest values for lipstick are between 5,878 0.010, for powder between 5,898 0.010, for eyeshadow between 6,400 6,142 0.030. Conclusion. This study investigated the concentrations of trace elements in halal certified cosmetic products. Halal certified cosmetics were analyzed for the first time using microwave digestion with ICMMS. The nitric acid and hydrogen peroxide digestion method was successfully applied for the determination of multi-element contents. The concentration of aluminum, chrome, manganese, iron, cobalt, nickel, copper, zinc, mercury, cadmium, selenium, and lead in the analyzed halal certified cosmetic products were in the range of 5,817 0.010, 5,817 0.010, and 6,114 to 0.030. Lipstick, powder, and eyeshadow respectively. Copper levels in all samples were below the detection limit of the method. Aluminum brand 1 and brand 2 were found at the highest levels in all samples except powders. Iron brand 2 was not detected in lipstick and eyeshadows. Nickel was only found in the 2 brand eyeshadow. Solvents were found to contain aluminum, chromium, manganese, and cobalt. Thanks for listening.
Bismillahirrahmanirrahim. My name is Hassan Ahmed from Sudan. I am doing my PhD in analytical chemistry in Erciyes University, Kayseri, Turkey, with my supervisor, Professor Dr. Mustafa Soylak. This is the last year for me. I would like to present our work to you. This is part of our works. This efficient solid phase microextraction for gold and palladium using ZIF cobalt at tungsten selenide nanocomposite. We should know about what ZIF does mean. ZIF is belong to metallo-organic frameworks or MOF. MOFs are a class of porous crystalline compounds consisting of endless lattice of inorganic secondary structure unit and organic binders connected by medium strength coordination bonds. They are also a class of materials with remarkable properties including high porosity, large surface areas, and flexibility. MOFs application including gas storage, catalysis, separation processes, and even biological applications. Their tunable structure, biocompatibility, and biodegradability make them promising candidates for innovative drug delivery system and biological floaters also. MOFs represent a bridge between chemistry, materials, science, and engineering. Transition metal dicarbonides or TMD, tungsten selenide is a member of this family, which are two-dimensional materials known for their unique properties. It has a layered structure which contribute to its distinct electronic and optical characteristics. It possesses a band gap, making it suitable for use in electronic and optoelectronic devices. It exhibits excellent absorption properties for metal ions, making it ideal for extraction applications. Our study highlights, as you see in the right side, we have a graphical abstract of our method. The first process was synthesis of ZIF-L cobalt at a tungsten selenide nanocomposite using sol gel and hydrothermal techniques. Then application of nanocomposite for effective separation and pre-concentration of gold and palladium in geological samples. Finally, subsequent analysis of separated metals using flame atomic absorption spectrometer. This is the characterization result of our new nanocomposites, XRD in the middle, then we have FTIR's spectra. Then we have in the right side we have the scanning electron microscopy images, and then we have SEM ADX images, and the characterization result agree with the literature. We also have electroanalytical characterizations like CV, voltammograms, LSV, EIS, Nyquist, the plot for bare surface printed electrode result. The test procedure, as you've seen, we have prepared ZIF-L cobalt with sol gel method. Then we have covered it by tungsten selenide. We use hydrothermal method for preparation of tungsten selenide on the surface of ZIF-L cobalt. We have also the pre-concentration method in this slide. We use few time from the beginning to the end. This is a simple method. The optimization results, we have a lot of optimization results, but we have selected the important for optimization, like pH. We use pH from 3 to 10. We test this pH with buffer solution. We have selected pH 5 as state buffer solution as optimal pH. For absorbent amount, we tested absorbent amount from 2.5 milligram to 20 milligram. We have quantitative result from 10 to 20 milligram. We have selected 10 milligrams as optimal absorbent amount. For ligand amount also we tested from 0 to 20 to 200 microgram from ligand. Our ligand is PADAP, PADAP. We have selected 100 microgram as the optimal. For L1 type, we tested 6 different types of L1. We have quantitative results at 4 L1 types. We selected the last 1.05 molar of thiourea in 0.05 molar HCl. This is the matrix effects. We have tested these ions in this concentration. Our results were quantitative and were ranging from 91% to 101% as recovery values. For real sample, we use 5 samples, 2 are rocks from Sudan, from mining area. 3 samples are covering sample. They are used in Erbil University Technology Research and Application Center for covering samples for XRD and SEM analysis. Uh, This is the result of our method with flame atomic absorption spectrometer. We have validated our method with ICPMS. There are agreement of two method when we use t-test in confidence level 95%. In conclusion, our technique is proposed technique unaffected by matrix constituents like alkali and earth alkali metals and transition element in environmental samples. Newly synthesized adsorbent provides simple, cost-effective, and efficient means for pre-concentration and precise measurement for gold and palladium in geological samples. Demonstrated high sensitivity and accuracy in metal analysis. Thank you very much for your attention.
Bismillahirrahmanirrahim. Hello everyone. Today I will present my work on tailoring and characterization of activated carbon cloth and LDH nanocomposite as a competent adsorbent for lead and nickel extraction for environment samples on the platform of 5th ICMMS conference. I thanks to the organizer of the conference to give me this opportunity. I am Dr. Muhammad Bilal from Pakistan, working as a assistant professor in University of Karachi. Nowadays, I'm working as a postdoc scholar under QBTAC research project under the supervision of Dr. Mustafa at Erbilgin University. He is a well-known analytical scientist, and he is also the keynote speaker of this conference. These are the contents of my presentation. I will start with introduction and background of my work. After that, aims and object, experimental work, result and discussion, conclusion and references. Introduction. As an analytical chemist, we face a lot of problems during method development because of very low concentration of analyte in different environment samples and their metals. So we developed a different strategy to pre-concentrate the analyte and reduce the method setup. For this purpose, I studied activated carbon cloth. Carbon cloth are widely used as an adsorbent due to their high efficiency. They have large surface area, force volume, and easy to handle. These are the same images for carbon cloth at different zoom scales. Second material I studied is LDH, layer double hydroxide. They are hydrotelside-like compounds consisting of positively charged metal hydroxide layer interleaved with a negatively charged anion. They have general properties in the sense of they have high surface area, structural water resistance, making them easy to use. They have a catalytic ability, anion exchange capability, thermal stability. Because of that, functionalities, easy preparation and low cost, LDH have been widely applied, particularly in analytical chemistry like sorption, catalyst, drug delivery, and so on. Aims and object. The aim of my work to hybrid the excellent adsorbing capability materials and synthesize a new material that is more sensitive, more efficient, and easy to use. In my present work, a novel nano composite of activated carbon cloth with layer double hydroxide, manganese, cobalt, aluminum has been prepared by using a hydrothermal method. And according to the literature survey and best of my knowledge, this one is new and has not been used as an adsorbent. This material is used for lead and nickel determination from food and environment. Experimental work. So the graphical presentation of my work. First, I synthesized a new material by hydrothermal method in which I took carbon cloth and cut into the small pieces and activate them. And after that, prepared a LDH material and put together into the hydrothermal reactor for 12 hours at 160 degrees centigrade. And after characterization, we show the data suggested that the LDH nanocomposite material is successfully synthesized. And after preparation of the adsorbent, I developed a method and optimum all parameters like pH, adsorbent amount, time, centrifugation time, sample volume, volume, and all of that. After that, I analyzed through flame atomic absorption spectrophotometric. The developed method will also apply on food and environmental samples. Result and discussion. For to develop method was optimized by standard protocol like pH optimization, amount of adsorbent, desorption time and adsorption time, sandification time, sample volume, and eluent volume. pH checked from 0.3 to 9 and found good recoveries and pH 8. For evaluation of the amount of adsorbent, 7.5 milligram show the maximum result of both element. And for the determination of pre-concentration factors, sample volume and elution volume was optimized. For nickel, 30 ml and 1 ml got maximum recoveries. In the sense of lead, 25 ml and 1 ml got a maximum recoveries, and we calculate a pre-concentration factor accordingly. And also we evaluate the eluent concentration. Means here we are using nitric acid and eluent, and we got maximum results at 1 molar concentration of nitric acid. This slide shows the effect of interference sign on the developed method. During the determination of lead, and nickel recoveries was found greater than 95%, which is indicated there is no interference sign present during analysis, and the developed method is selective and suitable for lead and nickel determination. After determining the optimal condition, we calculate analytical figure of merit of the developed method and find and calculate limit of reduction, limit of quantification, pre-concentration factor, enrichment factor, extraction efficiency, and person related standardization of the method. For the validation of the proposed method, we use a certified reference material, and the obtained result data show the excellent correlation with the certified values at 97.5 to 102.4% confidence level. For the validation of the developed method and check the matrix effect, we also apply standard addition method for on noodles, tap water, and juice samples, and it was demonstrated that the accurate quantitative results were obtained by comparing them with the added amount. The table shows mean concentration of lead and nickel in water, noodle samples, and different flavor juice which we collect in local market, Kastel, Turkey. And we found that the mean concentration of lead in noodle is 66 to 123 microgram per kilogram. We also calculate the estimation of daily intake. How we calculate in the sense, for example, the concentration of water of nickel is 70, and we took 3 liter, then we took 51 microgram nickel per day. Our body weight is 70, then we calculate this in the sense of 0.72 microgram. In the sense of noodle, if we prepare noodle, we take 300 ml water, one packet masala, and 170 gram noodles. This contains 712 microgram per kilogram nickel. And if this one is 70, the amount is 22.2. And for calculating the sense of per kilogram body weight, that way the amount is this. The estimation of daily intake also calculating the sense of juice. If one dose is 200 ml, the amount is 2.21. And the average weight of body is 70, then the amount of nickel to one dose is 0.03 microgram per day, body weight per day. After calculating estimated daily intake, we compare this value with WHO recommended PKDI value. For lead, this one is 3.6, and for nickel, this one is 5. We add all of that and divide it by body weight for child and for adult, This value is 3.12 and 1.37 for children and for adult. This one is lower than the recommended level, and we are saying in that mean if you are using this on one time, and this one is okay. If you take into 1 or 2 or 3 times the same food, then this will be cross from that. The well procedure is found highly sensitive, accurate, maximum selectivity, and having good absorption capacity for lead and nickel determination through FAS. And in the sense of PTDI, means preventional tolerance daily intake of lead and nickel intake of children through food, juice, and water is calculated as lower than the WHO recommended level. However, the quality of water matters. Lead and nickel level during noodle manufacturing and cooking as well as. Therefore, to ensure the safety of children, it is recommended to choose brands that adhere to strict quality control standards and regularly monitoring the level of toxic metal in their products. Think before it is too late. Moderation and balance are the key to ensure children's overall health and well-being. So, to encourage children to enjoy diverse range of nutrition food, not all the time noodles. It is all about my work, and thank you for your listening. This is my research group. My pictures is with Mustafa Solid and other research fellows working in this Solid group. At the end, I say thanks to Tubitech for funding to the research. Thanks.
Hello, everybody, and thank you for the organizers to give me the chance to present my talk. My talk about effect of germanium oxide on the structural aspects and bioactivity of bioactive silicate glass. And this is me, Ahmed Farghali Mabed, X-ray crystallography lab, Physics Institute National Research Center. My talk will go through introduction about the work, aim of the work, methodology, results, and finally, what is the outcomes? For starting, we should know what is the bioactive glass. Bioactive glass materials is one of the biomaterials family, is composed of three-dimensional networks of silicate or phosphate, and most of them are based on sodium oxide, calcium oxide, phosphorus pentaoxide, and of course silicon oxide. Firstly, was invented by Larry Hansch, famous professor at the University of Florida in USA, and this was in 1969. So, what is the applications of bioactive glass and why is bioactive glass is a very important one? Let's see. Bioactive glass materials can easily interact or attach to soft or hard tissues and they make chemical bonds, which means that it open the doors for bond cement applications, dental applications, and also it can be available in different forms, liquids forms, solids, and whatever the forms we need to a specific application. So it's also a positive point for the bioglass materials. So what is the aim of our work and why we choose to study bioactive glass materials? Bioactive glass materials is very important because they have great applications for human biological systems and others. And we choose to develop bioglass materials using germanium oxides to get more compatible, biologically compatible bioglass systems and with stronger and antimicrobial activity, which make it more useful and promising for medical applications in bone cement and dentals, and not only this, also in drug delivery and cardiovascular applications and many biological applications. So now let's see what is the methodology or how we can perform such a study. The first step was molecular modeling. It's very important to predict the structure geometry and to predict the electrostatic distribution and what is the most probable site for to make chemical bond with biological systems. As far as I know, there is a few case studies for molecular modeling for bioglasses in literature. And this was done at the molecular spectroscopy and the modeling unit at National Research Centers. Was kind and great effort was Professor Midhat Ibrahim and his group. Thanks for him. After make prediction and molecular modeling, it was the first step to experimentally prepare the samples. And we used sol gel techniques. And with kind effort with Dr. Taha Taima. He is already in the picture. And then we have samples. What we'll do with the samples? Samples actually want to throw many characterization techniques and assessment to firstly ensure that already sampled formed and then to follow the changes in the physical properties and what this reflects for the biological activity, and also finally to see what is the impact of these changes and the properties on the biocompatibility and the biological application. So started with to study the thermal behavior of samples with differential scanning calorimetry, and follow the changes in the crystalline state, and to ensure that the samples already exist in the crystalline form using X-ray diffraction, powder diffraction techniques, and FTIR. Also to study the mechanical properties of samples with mechanical test, and to see what all of these characteristics affect the bioactivity, especially for antimicrobial, minimum inhibitory, and cytotoxic activity. Finally, to see what will happen with the biological systems using simulated body fluid experiment. So let's see the results. What will tell us? Molecular modeling, it was very important results. Predicted this geometry of our samples and the electrostatic distributions, and showed the electronegativity, which means that there is a strong possibility for these materials to form chemical bond with biological systems, and of course to form a hydroxyapatite. So let's see what's X-ray told us. X-rays follow the changes in crystalline state across all the stages of the experiment, starting from preparing the bioactive glass before adding germanium oxide, then after adding germanium oxide, and also after adding polyacrylic acids. So it was two questions. Is it the samples formed? Then what is the crystalline state? Is amorphous or crystalline? And what is the crystallite size? All of these structural characteristics, of course, will affect completing the study and affect the biological properties and so on. So what will happen if we haven't crystalline shape, if we haven't crystalline sample? So what will, how we can know if the hydroxyapatite or the samples already interact with the biological system or not? So in that case, IR is very important, because even sample crystalline or not, we can use the IR spectroscopy to see the band of hydroxyapatite. As you know, when the bioactive glass using simulated body fluid technique, this is similar like dental environment. So we can see if we have hydroxyapatite, then the samples interact with the biological system and the biocompatible for dental applications and the medical applications. And of course, we can see the band of hydroxyapatite in IR spectroscopy bands. And also the mechanical test to be sure about the mechanical properties of materials and how the crystalline state and other properties affect the mechanical properties. And also the results tell us that adding germanium oxide increase the mechanical properties and the shear bond strength of materials. And there was the strongest of the largest value at the 25% of germanium oxide. And after simulated body fluid experiment, we can see that the most crystalline one and the clearly hydroxyapatite is appear here using germanium oxide with the percentage of 25%, which is the strongest candidate for medical applications, which also inconsistent with the results of mechanical properties and other characteristic techniques, which of course will affect and see on the next slides for the biological applications. Here, antimicrobial, minimum inhibitory concentrations, and cytotoxicity, we see germanium oxide here enhance all of these, and also which make it much better and useful for dental and biological applications. So after that discussion and the results and what have done, what is the conclusion? Conclusion that germanium oxide, adding germanium oxide for bioglasses enhances the structural characteristics and bioactivity and the antimicrobial properties and the mechanical. Which means that? What this mean? This means that adding germanium oxide for bioglass make it much better, much useful and promising for dental applications and biological applications, which already confirmed with the simulated body fluid experiment, which showed promising biocompatibility, especially at the germanium oxide at percentage of 25%. This work, part of this work already published at Scientific Report Journal, and still we develop and make development and enhancement for this work. Hope it be useful for the dental applications and the biological application in different medicinal fields. And finally, thank you for giving me the time. Thank you for interest, and I'm ready for discussions and more details. Please send me. Thank you all. Thank you.
Hi everyone, my name is Haitham Khalil. I am from Cleveland State University, Cleveland, Ohio, United States. And also my first affiliation is with the chemistry department, Suez Canal University, Ismailia, Egypt. Today I'm going to talk and share my findings about the project related to early prediction of recurrent non-muscle invasive bladder cancer using ATR, FTIR in urine samples. I want you to take a minute and imagine a friend or a relative has been diagnosed with bladder cancer, and after the tumor's removal, he or she undergoes a 5-year follow-up plan. Every 3 months during this period, a thin tube like this will be inserted to check his or her bladder for any signs of tumor recurrence. This examination is called cystoscopy. Despite the pain and discomfort of cystoscopy, the 5-year follow-up plan is significant in maintaining a survival rate of approximately 96. According to the American Cancer Society, ACS, bladder cancer ranks 6th among the most common cancers in males globally and 4th in the United States. 1 in 27 men and 1 in 89 women will be diagnosed with bladder cancer at some point in their lives. In the United States, the rates of bladder cancer have increased in recent years. And finally, in 2023, only 82,290 new cases of bladder cancer have been reported, and about 17,000 deaths from bladder cancer. Quick facts. Bladder cancer is the most common in men. Men are about 4x more likely to be diagnosed with bladder cancer than women. And the big challenge is that bladder cancer has the highest recurrence rate of any known cancer. Some warning: according to the WHO, Egypt and USA are amongst the highest rate of incidence of male bladder cancer. It's not only male, it's also females. So Egypt and USA are amongst the highest rate of incidence of female bladder cancer. In terms of mortality, and due to the deficiencies in Egypt's healthcare system, the country has one of the highest mortality rates in the world for bladder cancer, as reported by the World Health Organization compared to the United States. The non-muscle invasive bladder cancer is mostly a low-grade tumor with 3 types or stages: the TIS, the TA, and T1, and all can be occurred in the bladder lumen. The current situation. So the high recurrence of non-muscle invasive bladder cancer requires frequent examination, as we know, to check for the tumor recurrence. Cytological analysis is one method. CT and MRI are another way for examination. But cystoscopy is the gold standard method. However, it has some drawbacks, such as it is invasive, painful, risky, cost-intensive, and operator-dependent. So that's why researchers are working on the development of non-invasive diagnostic tools for bladder cancer that are both sensitive and specific. These tools aim to improve early detection rates and reduce the need for invasive procedures, ultimately leading to better patient outcomes. And this is what we want to improve the detection and reduce the complications. An overview on the experimental design. After sample collections from the patients, we have sample loading on the IR crystal, then drying under a gentle stream of nitrogen followed by FTIR measuring, then feed all of these data into machine learning for signal processing to end up with a diagnostic algorithm and IR signature for the recurrence patient. Here is the million-dollar question. Why FTIR? Why we use the FTIR? We can answer this. The FTIR is the affordability of FTIR, the simplicity of FTIR, the user-friendly of FTIR, the promising data we can get it from FTIR, the fingerprint that FTIR can provide for us, the snapshot of complex biochemical profiles of clinical samples that FTIR can provide in few minutes. In terms of our results, first, a total of 62 patients were recruited after a transurethral resection of the bladder tumor of non-muscle invasive bladder cancer, and this transurethral resection means after the cancer removal they actually entered the 5-year plan of follow-up. And during their visits, we collected the urine samples side by side with the cystoscopy. And the urine samples were collected during their regular follow-up visit were stored at -80 for the FTIR assay. The FTIR full range spectra were recorded after that from the 500 to 4,000 centimeter -1. We were interested in two regions, so that's why we selected two areas of interest where the fingerprint region can be existed, or we anticipated these two regions are the most important regions for lipid hydrocarbons. The first region started from 700 to 900 centimeter -1, and the second region were from the 2,800 to 3,000 centimeter -1. Using the principal component analysis, the PCA, and other models of signal processing, we confirmed that any technical variability was lower than the biological signal, where the distances between the replicated spectra were significantly lower than for spectra from patients. We used Wilcoxon rank and some test, and the probability or p-value was lower than 2.2 times 10 to -16. We succeeded to find an IR signature for recurrence patients from 2,800 to 3,000 centimeter -1 with 86 sensitivity and 77 specificity. And it's very clear here the red spectra is for the free patients, while the black signature, the black spectra, was for the recurrence patients. And this is the big and promising data that can be reliable and used for non-muscle invasive recurrence diagnosis. Our conclusion started with this data, or this project can provide a rapid and direct spectroscopic assay using very simple technique, which is FTIR. We reported for the first time that the CH2 lipid asymmetrical fingerprint as an indication of non-muscle invasive bladder cancer recurrence. Our technique provide a promising non-invasive diagnostic tool for the early detection and intervention of non-muscle invasive bladder recurrence. And finally, we are aiming to enhance the current assay and assess for a larger cohort for the non-muscle invasive bladder cancer surveillance. And recently, we have successfully published our preliminary results in the Journal of Molecules. I would like to end with these remarks. Our ultimate goal that we hope to replace cystoscopy with the FTIR to improve the management of patient surveillance and reduce the cost patients follow-up. So we can move from this thin tube to a cup of urine, and using the FTIR easily and simply in less than few minutes, we can determine if the patient is free or he or she has a recurrence tumor. I would like to thank the Institute of Biotechnology for postgraduate studies and research at Suez Canal University. I would like to extend the thanks to the Department of Urology, Faculty of Medicine, Suez Canal University. I also would like to thank the Walter Eliza Hall Institute of Medical Research. And of course, I would like to thank the host institute here in the United States, the Cleveland Clinic, Lerner Research Institute, and Cleveland State University. And thank you all for listening to the presentation, and I will be happy to answer your question.